What's happening, guys? Today we are in section 4.6 and we will be performing operations with complex numbers, okay? And complex numbers is something you may or may not have come across yet. Here is a complex number, okay? And I will definitely be explaining what this is, okay? The very first thing we need to do is talk about some vocabulary, imaginary numbers. And what an imaginary number is, we're going to use the letter I to represent that we have an imaginary number, okay? So I, an imaginary number, is equal to the square root of -1. Now why is that? Here is why. You cannot take the square root of a negative number, okay? You can't take the square root of a negative number because that would imply that two identical numbers, when you multiply them together, would give you -1. Okay? Think about that for a second. Can you take two of the exact same number and multiply it together and get -1? Okay, think about it. When you take the square root of a number, say you take the square root of 25, right? What does that equal? Well, it equals 5, because 5 times 5 gives you 25. Okay? So whenever you're taking the square root of a negative number, it's impossible. So you end up getting an imaginary number, and that's what we're going to use I for. Notice if I was to square I, if I go I times I, wouldn't I get square root of -1 times square root of -1? And by definition, that's going to equal -1. Remember, what's the square root of 7 times the square root of 7? Well, it's the square root of 49, which equals 7. The square root of 7 times the square root of 7 equals 7. The square root of 10 times the square root of 10 equals 10. So the square root of -1 times the square root of -1 equals -1. That's what happens when you square the I. Okay? And finally, a complex number is just going to be written in this form right here. This guy right here is your real term. And this guy right here is going to be your imaginary term. Ooh, my hands feel all weak. I just got back from a 5-hour motorcycle ride, over 5 hours, 5.5-hour motorcycle ride, and my hands are a little, not numb, but definitely kind of weak from gripping for so long. Okay, so here we go. Let's talk about some imaginary numbers. Let's do a couple examples and you'll see what I'm talking about. It's pretty straightforward. I'm going to give you just simple stuff. Okay, so part A, imaginary numbers. All right, here's our first example. All right, the square root of -4. Okay? All right, now think about this. If that negative sign wasn't there, if all it said was the square root of 4, well, wouldn't you say 2? Okay, it's 2. But since it's a -4, it's not really a 2. It's an imaginary 2. So we're going to put 2i. That lets us know that it's an imaginary 2. Okay? Now, if I was to multiply this back, I'll show you. 2i times 2i, well, what's 2 times 2? That's 4, okay? And what's I times I? Well, I times I is I squared, right? And what is I squared? It's -1. So 2 squared is 4. I squared is -1. 4 times -1 is -4. There we go, okay? So working backwards, we can get that. All right, let's do another one. How about the square root of -12? All right, so we get, this is how I'm gonna break it down like this, just so you can see it, okay? The square root of -1 times the square root of 4 times the square root of 3. Okay? And watch what I get. I get this right here. Well, according to this, the square root of -1 is I. Okay, so I get I. The square root of 4 is 2, and the square root of 3, we just leave it as the square root of 3. So we're going to write this in the correct order. We never write the I first. It's always going to be 2i radical 3. Okay? All right, here we go. Let's solve some equations. Let's solve some quadratic equations. Part B. All right, let's try this. Example. We have x squared minus 8 equals negative 36. All right, now I don't know if you remember, but in our last section, whenever we had the x squared and we have the c term, so we have the a term and we have the c term, we don't have a b term. Remember the b term has an x next to it? Anytime we just have the a term and the c term, go ahead and move this guy over so we end up with this. X squared equals, you're going to add 8 to the other side, okay, so this is going to equal negative 28. And now we're going to take the square root of both sides, so take the square root, okay, x squared, take the square root, equals negative 28, we'll take the square root, okay. Remember, every time you take the square root of both sides, you have to put plus or minus, okay. All right, and now the square root of x squared is just x equals, now this is plus or minus, I'm going to write it in all the different factors, okay? So I know that 28 can be broken up into the square root of 4. Since it's negative, it's going to have square root of negative 1. And then it's square root of 4 times square root of 7 gives you square root of 28, so square root of 7. Now I wrote it like this because now watch this. Ready? X equals plus or minus. Square root of 4 is 2. Square root of negative 1 is I. Square root of 7 just stays like that. Okay? Pretty straightforward. All right, again, if this is going too fast, just pause it, rewind it, play it again. Okay, example. Let's try another one. Let's try 5x squared plus 33 equals 3. 5x squared plus 33 equals 3. Okay, all right, so we have to get the x squared by itself, just like we did over here. We added the 8. Over here, we have to subtract 33. So we get 5x squared minus 33 from both sides is going to equal negative 30. Now we have a 5 there, okay, so we're going to divide by 5, okay, and we get x squared equals negative 6. Okie doke. And take the square root of both sides, so x squared, take the square root, equals negative 6. Take the square root. Don't forget to put plus or minus. Okay, and the square root of x squared is x equals plus or minus. Now since it's negative, we're always going to have an imaginary number, so it's imaginary. And the square root of 6, we can't really break that down, so just leave it as the square root of 6. So we get x equals plus or minus I square root of 6. All right, let's do a couple more problems. Let's do some addition and subtraction of complex numbers. This isn't too hard. So part C. Addition and subtraction, add and subtract complex numbers. All right. And here's our first example. I'm just going to do a subtraction one, okay? I don't think we need to spend a lot of time on this. It is 7 minus 6i minus 3 minus 6i. Okay. All right, so let's remove the parentheses. There's a positive out here, so it's 7 minus 6i minus 3, and then the negative gets distributed to this guy, so plus 6i. Okay. 7 minus 3 is 4. Negative 6i plus 6i, they cancel, we're done, okay? So if we added this complex number and subtracted that complex number, we end up with a real number, okay? I'll do one more of them. It's not going to be that tough here. Let's just do this really fast. 10 minus 6 plus 7i plus 4i, okay? So here we go. 10 minus 6 minus 7i plus 4i. Okay, 10 minus 6 is 4. Negative 7i plus 4i is negative 3i. Okay, we have a complex component of negative 3, and we have a real component of 4. Okay, all right, let's do some multiplying. Part D. We have 4i parentheses negative 6 plus I. All right, we'll go ahead and distribute. 4i times negative 6 is negative 24i. 4i times I is plus 4i squared. Okay, keep in mind I squared is negative 1, so this becomes negative 24i plus 4 times, this is negative 1, okay, and we get negative 4, that's our real component, so we're going to write that first, negative 4, and here's our complex component, so minus 24i, okay. Let's do one more of those. Let's try, how about this? 9 minus 2i times by negative 4 plus 7i. Okay, so this is FOIL. 9 times negative 4 is negative 36. 9 times 7i, okay, is plus 63i. Negative 2i times negative 4 is positive 8i. Okay, and negative 2i times positive 7i is negative 14i squared. Okay, all right, so we have negative 36. We have positive 63i's and adding 8 more of the i's, so we get altogether plus 71 of the i's, okay? 63 and 8 is 71. And then minus 14, remember I squared is negative 1, okay? So now we get negative 14 times negative 1, that's a positive 14, okay? And a positive 14 and a negative 36, okay? That sounds like negative 22 plus 71i, okay? There's my real component, there's my imaginary component, okay? All right, there's one more thing I want to show you. I'm not sure if you're going to run into this, but just in case, check it out. Here's an extra little thing. What if I have something like this? 3 times x plus 1 squared, okay, equals, let's see, negative 30, okay? Let's just try this really fast, then I'm done, I promise, okay? Divide this by 3, so we get x plus 1 squared equals negative 10, right? Now we're going to take the square root on both sides, so square root that, don't forget plus or minus, okay? Now this, remember, becomes x plus 1, okay? The square root of something squared is just that, equals plus or minus, this is negative radical, so it's an I, and then this guy doesn't simplify, so it still stays square root of 10. The only thing we have left to do now is subtract the 1 to the other side. So this is what I want to show you to be careful. X equals, subtract that 1, you get it right here. That 1 becomes a negative 1 on the other side, and you still have plus or minus I radical 10. Okay, and we're done. All right, guys, good luck.